Hi, and welcome back to another video in my series about 6502 runtime and assembler running on this RetroShield. And as promised, I'm going to show you how you write your first 6502 assembly program. So we'll start with an empty file. I'm in this folder source samples asm, and we're going to call our file hello.asm. Do you want to make a new file? Yes. I'm going to call it a program because this is Hopper. So things are, your primary file in your project is called a program, and then your subsequent subsidiary files are called units, and you could use other people's units. And then you can add this signature for the main method of your Hopper program. You don't need to, but you can. And then if it's not doing syntax highlighting right now, it's a bit of a flaw, but if I exit and then edit it again, the syntax highlighting is there. Okay, it's ASM, so it knows it's assembler. So if I press F7 to build, it's on the build menu. I get an error message at the bottom that says define the CPU. So you can either define the CPU at the bottom, you can see at the bottom of the screen there, it's got a CPU. You can either define it for 6502 or 65C02S, which is the Western design one with the biggest instruction set. But we'll start by defining it for CPU 6502, right? There's also another setting where you can say how big your ROM is. So you can say, I want to make my ROM a very small ROM. It's going to be a 1K ROM, right? And that defines your entry point. It just assumes that the ROM's always going to be at the highest part of the RAM, the highest part of the memory map. So 1K ROM is going to start at, what's that, FC something or other. Anyway, if we build that, we'll get our minimal program, and it won't do very much at all. So let's go have a look at it. So it says it successfully built it. So we also go in here and we set that we want to run the optimizer, we want to run the disassembler, and we want to save automatically on build. We don't want to be prompted if we've made a change. So now here there's a console command called show, and I know in the debug folder there should be a hello.listing file that the disassembler created. And I'm going to send it through more in case it's got more than one page, but it's very small right now. So this is the smallest program that you can generate with the Hopper 6502 assembly toolchain. These are the interrupt vectors and the reset vector, and as we suspected, our 1K ROM starts at hex FC00. What does it do? It doesn't assume that the CPU is in decimal, that it's not in decimal mode, so it takes it out of binary BCD mode and puts it into regular mode. It's loading FF into X and then putting that into the stack pointer. So it's initializing the stack to a reasonable known location. You don't really have to do that since the stack is circular on page 1 anyway, but it makes it easier when you're in the debugger to see what the hell's going on. And then at the end of your program, it just calls the stop instruction and finishes up. You're done. That's it. A program that does nothing. So let's go make it do it more. All right, so let's say we want to have a string. So the syntax is very much like C or C# or Java. So my data, I'm going to call it, let's just make a string that says hello Hopper 6502, shall we? Like that. And it needs a semicolon because Hopper is all about semicolons and curly braces. So we build that again. And if we go up, there will be no change. And this is one of the benefits of using the Hopper assembler, is if you don't use something, it doesn't include it in the output. So we need to use it. So the one way to use it is we just say, let's load 0 into the Y index register, because to be able to use loading from a memory address, you need to use the index register. Well, there's limitations on the instruction set of this compared to the instruction set of the bigger one. That should just load the first character into the accumulator from our data. So let's see what that does. Back out again, show the listing. So yes, so now suddenly we've got a bunch of data in our file, and here are our new instructions. So it loaded from there the first character into our accumulator. Right, we're getting somewhere. And then we want to do something with it at some point. So, do something. with A, and then we want to increment the increment Y, and then we want to go around to the beginning again. So one of the ways you can do that in hopper assembly is there's something called a loop, and it's just like the hopper loop, but it's in 6502 assembly. So now what that does is brings us back around to load the next character, and load the next character, and load the next character. And we want to stop at some point. Now, there's some really convenient feature of doing strings as data in hopper, and that's that it puts a 0 on the end. They're null terminated, like C. Automatically does that. So let's go back again. So what we want to do here is we want to check. So in typical assembly, you'd say, compare it to 0, which you don't really need to do because the load A sets the 0 flag anyway. And then you're going to say, branch if equal out of here. Yeah. And you could put your out of here over here as a. So there we go. So let's build that. Oh, that's a debugging message we didn't need to see, but that's okay. Let's go see what that looks like. So yeah, so it compared it to 0, which it does, which is superfluous because load A sets the 0 flag, but it's just for illustration. And then if it's 0, jump out of here. And then you need to know that that is going to be less than 127, otherwise you can't use the short jump. So that's typically how you would code this. And there's the loop jump back down to the beginning. That FC19 just keeps running around in circles, right? So if you were doing this there's benefits to the hopper assembly. You don't need that label. You don't need that. You just say if the 0 flag is set, then what would you do out of a loop? You would break, right? And if I build that, it amounts to the same thing. By the way, that debug message is coming up in green is telling me something about the optimizers trying to get rid of my compare because it says it's superfluous. So the optimizer does all sorts of things. And behind the scenes as well, it'll make sure that this jump is within range. If it's not, it'll flip the condition, jump forward 3, and then have a second jump in there that's a long jump to get out. So it does that all automatically behind the scenes. It's kind of an advantage of using this assembler. Okay, so if we get rid of that comp, we'll get that error message will go away. There we go, we're getting somewhere. So now we've got a program that runs around in circles. It'll theoretically run through this until it gets to the 0 terminator and then break out. But now we want to do something with it, right? So at this point, we're going to start to cheat a little bit and use things that already exist. And that's why we have units. So we have users. And I know that under source runtime 6502, there is a serial unit. Let's see if I found it. Yes, I did. Okay, all that compiling, all the messages. Now, if I right click on that, there's the serial unit. And it's got things that, and it's what I've done to simulate the Motorola 6850 for this RetroShield device. So I'm simulating it in the but it works with exactly the same way as the device as you would expect it to. Is there a serial? Is there something available to read from the serial? Wait for a character, which waits for that and then reads it. It's got a couple of other APIs. It's got a write character. Yep. Okay. So these look like methods. They look like functions. So the first one we wanted to call was serial initialize. So in addition to serializing the Motorola chip, it also serializes the circular input buffer. And then where we wanted to do something with A here, we're going to do a serial write char. So these do look like functions as they would in a semicolon or curly brace language, but the difference is they don't have arguments and they don't have return values, because in assembly you could do that anyway. You could return your result on the stack, you could return your result in a register, you pass the arguments in registers. So but what they do is this means that if we build this now, it'll only use the code that we've included. So even though there's quite a lot of code, inside this unit. And I mean, it's bigger than that. It's like there's this big memory map. Well, it's not so big. 0-page allocations in here. It's quite a lot of code being included. But if I build this, it'll, oops, serial initialize 0 doesn't exist. Good, yes. Oh, actually, I'll leave that in there. If I build there, if I want to go to my error, I just double click here. Double click on the status bar and the cursor will go to where the error is. Build again. All right, now let's go look at our assembler again. All right, so good thing I said more because there is more. So now my hopper thing is calling 2 methods. There they are, that's their addresses. That's where they've been assembled to. This is the initialize method. It, like I said, it initializes the, inside the serial unit, it initializes the input buffer. And then it also calls serial device initialize because we're using a specific device, and that's this 6850. Write character doesn't do a whole lot. Well, it actually just calls the serial device. So this is including another unit, the serial device. And in the serial device, this is what write character does. So you can see it's doing things with the ports on that 6502 chip, I mean the 6850 chip. And then I can either use interrupts to poll for read, or I can just call them occasionally. And it's doing that in the, it's polling them when I'm saying, is there a character available? And then we still got our vectors there as well. So our program got a little bit bigger, and it's included in both the bits we're using. And then I'm going to do one more thing, just to make it so that it's more obvious what's going on when we run this. I'm going to wait for a character here, serial wait for char, I think it's called. Let's see if that's, if I guessed correctly. Yes, there's our program. Okay, so I think we're ready to get onto our device. And in addition to creating the hex output, it also creates, I've made it create a C version of the hex file. Let's see if, so if I bring that into the editor, so it should be in the bin folder, it should be called hello.c. There it is. So that's our code, and there's not much in this file that's not zeros, so we haven't even used that much of our 1K ROM. So we select all that, and then we're going to copy it to the clipboard. And then this is the same Teensy setup that I had in the previous video, when I was showing you how to get your firmware installed on the Teensy. But instead of the Hopper firmware, we're now putting our little program on it. So we're only putting a little 1K ROM onto the Teensy. So there's no Hopper runtime on the Teensy, just our little 1K Hello World program. So we're compiling, and there's some flashing lights happening on our Teensy in the video. I can do that again. Showing that properly. Let's do that. Let's do that again. So we should see some flashing lights. There we go. Little flashy lights on the Teensy as it uploads. Very good. Okay. Now we can go back to Hopper. And we can get out of that screen. Right, now we're in the Hopper environment again, and let's see if we've got a port. Takes a little while to initialize. Yes, we've got COM port. Now there's another utility at the Hopper console called the terminal. It's going to prompt me for port again. I'll say I want to connect to that port. As I connect, it's going to initialize, and there we go. Hello Hopper 6502. And now I said wait for a key and then loop around again. So if I press a key on the keyboard, if I press enter, we get another one and another one and another one. But we're not getting empty lines. So let's improve on that. Okay, let's go back to our program. Hello ASM. And let's output an empty line. So how do we do that? Load immediate, a new line, OA. And let's write that character out. So we want to put a new line out after the end. And then we build that, compile, compile, compile. Go back out. Pull up our C here. Switch to the full screen so we can say copy that, paste it into there, wait for the flashy lights. I'm going to upload that to our Teensy. There we go. So we've got a new tiny little program sitting ready to run on our 6502. Okay, let's go back to our environment here. And let's switch to full screen and run our terminal again. There we go. And if I go enter, now we're asking to loop around, and we've got an exit, an end of line at the end of it. Anyhow, I think that's a fine place to stop. That's how you get your own assembler program up and running using the Hopper assembly toolchain on one of these devices. I will do a follow-up video. There's one more part of the toolchain that we haven't seen yet. I've written a 6502 emulator and debugger that runs on Windows, and I'll do a tutorial on how to use the emulator, so you could actually step through your program and debug it, which is kind of unusual. There's not a lot of those around for 6502. Thank you for watching. Enjoy the rest of the playlist. And there's another playlist on Hopper on 6502 beyond this device. You'll just have to find it on the channel.